Welcome everyone to the channel CSAI Think Tinker Learn. Today we are doing a deep dive into Redis, not just the commands, but the internals. Specifically, we are tearing down persistence and messaging. This is the stuff that separates junior engineer from seniors who understand how to design for failure. Before we begin, don't forget to like, share, and subscribe to support the channel. Also, take a moment to look at my companion website, which is bitbytoken.com. The link is in the description. This is divided into further four separate disciplines for software engineering, data, machine learning, and AI engineering. Each of them have again the fundamentals which you can look for. Say, for example, you want to look. These are further divided into basics, advanced, and expert. Um, then you can look at the sample solutions for them, how to design Instagram, rate limiter, and so on and so forth. Take a moment to go through here. If you like it, please let me know. Even if you don't like it, just share me your feedback so that I can make it better. Now, coming back to the topic for the day. All right, let's get it started. Okay. Redis is famous for the speed. Microsecond latency because your entire dataset lives in a physical RAM. But that is also its greatest fragility. A power blip, a kernel panic, or a hardware fault, and that data is gone, wiped permanently clean. Our job as engineers isn't just to make things fast, it is to architect systems that can survive a crash. Let's look at our survival options. The first persistent option is RDB, or the photograph fault. It uses copy on write. When you trigger a BG save, or the OS forks the process, and the child process writes the .rdb binary snapshot to disk. The parent and child shares memory, and the pages are only copied if the parent modifies them. The failure point? High write rates during a snapshot can trigger massive memory spikes. You must monitor the RDB last cow size metrics. If that spike hit your RAM limit, the OS will start killing processes. Let's quantify the data loss risk with RDB. If the server crashes 4 minutes and 30 seconds after your last snapshot and you are running at 10,000 writes per second, you have just lost 2.7 million writes. For a leaderboard or ephemeral cache, that might be fine. For a financial ledger, that's a catastrophe. This gap is exactly why the append-only file or AOF was built. AOF is the surgeon's log of mutations. It logs every single write command sequentially. On restart, Redis replays this log to reconstruct the state. It's stored in RESP, or Redis Serialization Protocol, which is human readable. You can actually edit this file to remove a buggy command if you need to recover a corrupted state. But remember the catch. Writing to the log doesn't mean it's safe on disk. Data is only truly safe once the OS flushes those buffers. How do we balance safety and speed? We use the fsync durability dial. Setting this to always is safe, but incredibly slow because every write waits for the disk. No is extremely risky. The industry sweet spot is every sec, where a background thread flushes to disk once per second. The main event loop is never blocked, and in the worst case scenario, you only lose exactly 1 second of data. If you have a counter that's updated a million times, a pure AOF file becomes massive and unmanageable. The solution is the mix format, the RDB preamble. Redis forks and writes a compact binary snapshot, then appends only new command after that point. This gives you the best both worlds, the fast restart speed of an RDB snapshot and the 1 second granularity safety of AOFs. Here is your persistent matrix cheat sheet. RDB is fast but risks minutes of data loss. AOF provides better fidelity but can get bloated and slow. Hybrid mode gives you the best balance. And if you get asked in an interview which file Redis loads on startup if both exist, the answer is AOF because Redis prioritizes write fidelity. Now, let's switch gear to messaging with PubSub. It's fire and forget broadcasting. Redis is the airspace, publishers are the towers, and channels are the frequencies. But follow the golden rule. If no one is listening when a message is sent, it disappears forever. There are no mailboxes, no queue, and no message replay. This is great for real-time invalidation, but it's not a message broker. Beware the O n plus M trap in PubSub. Exact matches matches with subscribe are fast, but glob style pattern matches with psubscribe require scanning a linked list. At scale, you have too many wildcards. The complexity of the publish operation becomes a massive CPU hotspot. Do not over rely on wildcards in your routing logic. Keep these 5 critical pub/sub failure modes in mind. First, slow consumers get disconnected if their buffers fill up. Second, there is no ordering guarantee. Third, entering subscribe mode locks your connection. You can't issue other commands. Fourth, there is no built-in auth for channels unless you enforce Redis 6 ACLs. Finally, the zero subscriber trap. A publish operation succeeds silently even if nobody received it. Always, always, always check the integer return value. If you need guaranteed delivery, stop using PubSub and upgrade to Redis streams. Streams provide a persistent data structure, at least once delivery, and global FIFO ordering. They introduce consumer groups and explicit acknowledgements. If a consumer crashes, the message stays safely in the pending entries list until the consumer recovers and acknowledges it. This is the architect decision tree. Need to manage state? Ask if every transaction matters. If yes, go hybrid. If no, pure RDB is fine. Dealing with messages? Ask if you need delivery guarantees. If yes, use streams. If no, simple pub/sub works perfectly. It's all about choosing the right tool for the constraint. Understanding which tool to reach for, and more importantly, why, is what separates a developer who uses Redis from an engineer who thinks with Redis. Don't just build toward speed, build for the failure state. I have a question for you. Have you ever had to recover data from a corrupted AOF or log? Or did you have to have a better persistence strategy in place? Let me know in the comments below. If you found this teardown helpful, please like, share, and subscribe. Thanks for watching, and I'll see you in the next one.